Hey guys, this is just a video on matrices, which are just for fun or for your future because you won't get tested on them in this course. But they're helpful for solving systems of equations. It's just a way to keep numbers a little more organized and more efficient. So usually when we have a bunch of equations, a bunch of unknowns, we like to stick them in a matrix and solve them that way, as opposed to just subtract, like doing elimination and substitution the way we've been doing in class. So I talked about this on Friday, but what you're going to do is write the coefficients and the constants only in our matrix. So we're going to make a big, kind of like a box. We're going to use a line for our equal sign, and we're going to write the first row, just the coefficients. So 1, 3, -1 is equal to -9. It's just writing the coefficients. So 1, -1, 1, and 11, 1, 2, 4 for the last row, 5. So we write each of these rows in a row of the matrix just using their coefficients. But these are all our x ones, these are all our y coefficients, and these are all our z coefficients, and these are all our constants in the last column. So we refer to things in the matrix as columns and rows. So this here is row 1, this is row 2, and this is row 3, and that's how we describe them. And then there's like okay, and then usually we represent a matrix with a capital letter, so this could be like matrix A. Alright, so our goal is, well, you could have different goals, but one thing we could do is reduce our matrix to have a bunch of numbers. So we could have like a number here, a number here, a number here, a number here. E, F, G, H, I. And all of these things are zeros. So we call this kind of like our main diagonal. And if we have everything under the diagonal equal to 0, it's really easy to solve this because now we know like z is equal to 1 or whatever. And then it's easier to solve the whole thing. And if we get it to this, that's called like it being in row echelon form. Then there's something I didn't talk about in class, that's reduced row echelon form, where you could actually have your matrix like looking like this, where only your main diagonal is left. So you'd have like zeros everywhere else, and all you would have is your main diagonal equal to your constants. And the reason that form is kind of cool is because now you can just say, oh, x equals b, y equals d, z equals g. Like it solves the whole thing for you if you can get it into reduced row echelon form. Or this form is also fine because it just helps you solve for one variable, and then you can take your next equation and subvariables into that. Alright, so check out our matrix. So essentially what we're doing is we're trying to solve for x, y, and z. So we're going to try to find this point where all these three equations intersect. So if this is like three planes, we're trying to find the intersection of three planes if they intersect in a point. Alright, so we're just going to do row operations. So you can multiply or divide a row by the same number. So like I could divide the whole first row by 2, or I could multiply the whole first row by 4. Whatever I want to do, I just have to do it to every number in the row. I could also add or subtract rows from each other, and I can interchange rows. And like I can move row 3 into row 1 spot. Okay, so the first thing I want to do is I want to make that a 0. So just looking at it, it looks like if I just subtracted it from, if I just do like row 1 minus row 2, I could make that a 0. Or row 2 minus row 1. So I'm going to leave row 1 the same. And then I'm going to do for this row, I'm going to do row 2 minus row 1. Or row 1 minus row 2. I'm going to do that. Okay, Okay, so 1 minus 1 makes that 0. 3 minus negative 1 makes that 4. Negative 1 minus 1 is negative 2. Negative 9 minus 11 is negative 20. And yeah, looks good. And then I'm just going to go ahead and do 2 steps in one. I'm going to do something to row 3. So my next goal is I want to make that a 0. So I'm going to do my same thing I just did. I'm going to do row 1 minus row 3 though, because I know 1 minus 1 is going to equal 0. 3 minus 2 is going to equal 1. Negative 1 minus 4 will equal negative 5. Negative 9 minus 5 will equal negative 14. Cool, so I just got these two to be zeros. And if this is our goal, 0, 0, 0, I just need this to become a 0. In which case I could do something like multiply it by 3 and then subtract it from, or multiply it by 4 and then subtract it from row 2. But I think I'm going to go for reduced row echelon form for this video. In which case I'm going to start at the top and I want to make that a 0. Okay, so to make that a 0, I am going to have to do row 1 minus 3 row 3. So I'm going to do row 1 minus 3 row 3 to get row 1 to be 0. So I got 1 because row 1 is 1 and 3 times 0 is still going to be 0, so that stays a 1. Then this number right here, 3 minus 3 times 1 is going to be 0. Then I go negative 1 because I'm doing row 1 minus 3 row 3. Okay, so negative 1 minus 3 times negative 5 would be 14. And negative 9 minus 3 times negative 14 will be plus, oops, sorry, 12, 42, negative 9, so 33. Alright, so that's what I just did to that row, because I'm going for a reduced row echelon. Okay, my second row, I want to make this 4 a 1, because I forgot to mention that, but in reduced row echelon form, A, E, and H are actually equal to, oh, that's row echelon. Okay, sorry, in reduced row echelon, these guys are actually just equal to 1. Okay, so I'm just going to move row 3 into row 2 spot because there's already a 1 there. So I'm just going to actually move row 3 here. So it'll be 0, 1, negative 5, negative 14. Cool, I'm getting close. And now the second row here, this guy, I want this 4 to become a 0, right? Because I want this to be a 0 here. So I'm going to do row 2 minus 4 row 3. So it's getting confusing. So row 2 is 4 minus 4 times 1 would make that a 0. And then row 2, so 0 minus 4 times 0 is still going to be 0. Row 2, so negative 2 minus 4 times negative 5 will be 18. Because that'll be like negative 2 plus 20. Then negative 20 minus 4 times negative 14 will be 36. So it's getting a little confusing, but we're getting there. Whew. Okay, so next step, we need both of these things to be 0. And we need that to be a 1. So we need those to be a 0. That's our goal here. Next step. All right. So how are we going to make that 14 a 0? All right, we could do this. We could do 18 times row 1 minus 14 times row 3. So I notice row 1's a 14 and row 3 is an 18, so I'm multiplying those rows by each other and then subtracting them so that they'll cancel out. So these will stay the same because, oh, I'm just minusing 0, so they'll be fine. And then this is going to become 0 because it's like 18 times 14 minus 14 times 18, so that's 0. Oh no, wait. This one will change actually because we're doing 18 times row 1. So 18 times 1 is 18 minus nothing. So this is going to become an 18. Okay, so that's unfortunate, but we'll fix it at the end. So 18. So then 33 times 18 minus 14 times 36 is 90. All right, row 2 we got to tackle here. So we need this 5 to be a 0. So let's do 18 times row 2 plus 5 times row 3. So we're just, since they have those coefficients, we're just switching them so that'll become a 0. Okay, so that's going to stay a 0. But then 1 times 18 plus 5 times 0 is going to be 18. This will end up being 0, and then the negative 14 will be a negative 72. And then finally, for my last row, I just want this guy to be a 1. So I'm just going to take row 3 and divide it by 18.
18.
Sorry, this video is super long. Okay, so that'll become 0, 0, 18 divided by 18 is 1, 36 divided by 18 is 2. It's almost done now, but it's been pretty long. Okay, cool, I'm almost done, but if I want it in reduced row echelon form, I need these guys to be 1s. So I'm just going to divide those rows by 18. So 18 divided by 18 is 1, those stay 0, and 90 divided by 18 is 5. So I just took that row 1 and divided it by 18. Then I'm going to do the same thing for this row. I'm just going to divide it by 18. So 0, 1, 0, and negative 72 divided by 18 is negative 4. And this row is good, so I don't need to do anything to it. Cool, so doing all those crazy row operations has left me with reduced row echelon form. So from reduced row echelon form, I can just pull out x equals 5, y equals negative 4, and z equals 2. So it's like the quickest way. So that's like the solution to our 3 planes. Solution to the system. If you didn't want to get it in reduced row echelon form, you could have just done it so that these things were 0, and you would have had no problem solving it from there. But if you want to do all your work using matrices, then you can get it to this reduced row echelon form. Cool. Not sure if that made sense, but in case it did, be ready for first year university.